I want, first of all, to thank the organizers of this conference. I know with the super energetic organizing system of KK Hua, he is probably already planning a conference to celebrate my 100th birthday. I can promise him now that I would certainly come to this conference. My talk today is remembrance of early days of particle physics. I enrolled as a graduate student at the University of Chicago in January 1946. I was really lucky. For a new era of physics, particle physics was just beginning at that time. Mesons, which earlier were called Yukons or mesotrons, had been discovered in 1937. After the war, there was much discussion in Chicago of its properties. I remember, for example, that before Chicago, I had visited Princeton and saw Wheeler. And Wheeler gave me a list of problems that he thought a graduate student of theoretical physics could tackle. I remember one of the problems that he outlined was to find out what is really the mass of the mesotron, whether it was 50 times or 200 times the mass of the electron. In late 1946, there came a surprising news. The discovery in Rome by Conversi, Pancini, and Piccioni. I would say that was really the first shot at the new field of particle physics. That discovery meant that the cosmic ray mesons did not interact strongly with the nuclei, contradicting the original idea of Yukawa. So they cannot be Yukawa's particles. This led to Marshak's two meson hypothesis of 1947. I, in fact, remember attending a conference of the American Physical Society at the University of Chicago. And Marshak, as a young physicist, was addressing a room overflowing with young physicists. Marshak's two meson hypothesis really said that there were not just one, but there were two particles. One, the Yukawa particle, later called pi, and the other one is decay product, later called mu. But actually, in fact, Powers Group in Bristol, using the new photoimmersion technology, had already discovered these two mesons. This is a photograph of the mosaic of the photographic immersion coming from Bristol. You see on the left side a pi meson coming in, stopping at the corner, at the southwest corner there, and decaying into a muon plus, we now know, a neutrino. And the muon would go toward the right and stopping eventually at the end of this mosaic. At that time, the photographic immersion was not yet sensitive enough, so one could not see the decay electron coming out of the mu. But a few years later, the sensitivity was greatly improved, and one could see pi mu e double decay. Here are four pi mu e decay photographs, which came very rapidly after the first discovery. These discoveries, in turn, led several groups in 1948 to 1949 to the theoretical ideas of one, universal Fermi interaction, two, separation of the strong and the weak interactions. Another big news was Rochester and Butler's discovery in Manchester of V particles, observed in October 1946, but that was published in 1947. These two are the photographs in that paper. You see this V-shaped thing, which is really the lambda decay into a pi and a p. That was the first strange particle discovered. But why is the decay of the V particle so slow? One knows, of course, that the V particle lived for quite a long time because it was produced in the plate, and yet it had to travel a little distance before it decays. If the particle interacts very strongly with other particles, then why did it decay so slowly? That led finally to Gell-Mann and Nishijima's strangeness concept. Another big experimental result was the discovery in 1948 to 1949 independently at Paris, in Bristol, and in Berkeley of the tau particle, where a tau plus decays into two pi pluses and a pi minus. This is a picture of the first discovery. At that time, the particle was called K. K is coming down in the middle toward the point A, where it decays into two pi pluses, which which are labeled A and B in this photograph, and a pi minus, which travels a small distance at the point B. It collides with a nucleus and fragments. Another front of development was renormalization. At the 1947 Shelter Island Conference, Lamb reported on the Lamb shift, and Rabi reported on Kush's experiment about the G value of the electron. In those days, things really moved fast, because these led to, within 2 years, Bether's calculation of the non-relativistic part of the Lamb shift, Schwinger's low-order renormalization calculation, Feynman's diagram, Tomonaga's papers, and Dyson's two great papers on high-order renormalization. These developments led to a recipe called renormalization, which in a sense provided a temporary conclusion to QED, a theory first developed in 1920s. This recipe amazingly produces calculations of minute effects which are in agreement with experimental results to an accuracy of 1 part in a billion. It's, if you pause and think about it, it's really unbelievable how the human mind could produce such great accuracies. Comments. The four old particles, electron, proton, photon, and neutron, were discovered over a period of 35 years, 1897 to 1932, or before World War II. Then immediately after the war, rapidly within 3 years, many new particles were discovered, launching the exciting new field of particle physics. 2, these new particles were essentially all discovered in war-torn Europe, in Italy, in France, and in England. 3, there were experimental discoveries in a continent where food was still rationed. It's really amazing. 4, then with the renormalization program, America began to take over from Europe the leadership in research physics, a position she still holds today. 5, amidst these challenging developments, I began my career as a graduate student in Chicago. I was really lucky. Of course, I did not realize it myself. Here's a picture of me in the summer of 1947 at the Devil's Tower in Wyoming. That summer, 3 Chinese graduate students of the physics of the University of Chicago, Gilbert Ling in physiology, T.D. Lee and myself in physics, bought a car and went for a 7-week trip of Western United States. I had later called that our Americanization. This was a picture taken of me. I was 102 pounds in weight. In that trip, we also went to Yellowstone. And here's a picture of T.D. Lee and me taken on the shore of the beautiful Yellowstone Park. Thank you very much.